Okay, this is another piece on the hardware in computing for you to look at. In the past, we've done peripherals. They're things that allow computers to get information from the real world, put information out, or store information for later usage. And also, there is also a group of peripherals for communication. They were all the peripherals. Last term, you will have done a piece that was on the internal parts of a computer system, and that's generally considered to be a processor, some form of input control, some form of output control, and memory. They're the core parts. Your investigation this time is into a processor and what actually goes into the processor itself. And what we've got is a processor. Most processors now actually follow something called the von Neumann architecture. That's where programs and data are all stored in the same memory. There is some other architectures like Harvard. Harvard keeps the program information separate from the memory information, which does have an advantage that you can't accidentally read uh, a program as data, or you can't create a virus effectively by having a lot of data hidden away in a program and then putting it into the programming memory. So what we've got is a basic processor. What you'll expect you to do is actually understand each of the parts, what they do, and what the acronyms are that are in here. And one of the easiest ways for me to explain this is if we do an example of a processor. This processor is going to do a little program. These assembly instructions, this is sort of human to computer level programming, a lot lower than Python. Each of these commands actually links over into actual machine code, which is purely numbers. So what this program does is it goes to the start and it says load into an accumulator. An accumulator is a little program, piece of memory, very fast memory built into the processor that stores the results of calculations. The hash M1 says whatever is stored in the memory location 1. So our program, when we go through it, it's going to take and load that number in. So let's do that instruction. So the first thing we look at is the program counter. The program counter says start at memory 0, and it reads in the instruction. And all it reads is that first byte, first of all. That gets processed into the instruction decoder in the current instruction register. And that starts getting processed, and that actually realizes, oh, I've got to go and get some more information from the memory, from this memory address M1, which is actually number 10. So it will actually go, what's the next byte of information? Gets that from the memory. And then it says, right, go and get from the memory address register. It will put the 10 in. The memory interface will go off, look at memory address 10, and bring back the value 4. So when we get into the programming register and the arithmetic logic unit, this first instruction it now knows I've got to take the value out of the memory address, the memory register, the bus register, the data value, and store it into this accumulator. The next command then it comes around and it says, right, I've used 2 bytes, so move the memory location on 2 places in the program counter, and that says go and get the instructions, and it pulls down the command ADC, which is to add, and something from a memory address, so it knows it needs to get a memory address as well. So the instruction decoder now says I'm doing the ADC command. It sets up the memory interface to go to memory location 12. That's where M2 is. Go to the memory location 12 and get the number at that point, 3. That's all then stored back in the memory bus register, and then we start processing the command. It says, right, add whatever is in location 12. So it goes back into the memory address, puts 12 in, says go and find out what value is in that memory address, goes and finds 3, brings it back into the memory interface. And it says now add that to my accumulator. Now the accumulator, we said a few moments ago, had the value 4. So it's doing 4 plus 3, and my accumulator now contains 7. That's still a register, still stored away in the program. In the CPU, it's not been put away anywhere else yet. So what we're going to do now is we're going to say, store this accumulator back into the memory address number 1. So the program counter looks at this address 4, pulls in the instruction, realizes 29 means store the accumulator, and it says, I need whatever address it needs. So take the address 10, find out where the address 10 is, set that up as being the address register. And then when it comes into here, it says take whatever's in the accumulator, put it into the memory bus register, and that will then store it into the memory. So those are what the pieces of the program is actually. We have a section which collects the program and its relevant information. It decodes what bits of circuitry are needed. Does it need stuff from the memory? Does it need stuff in the registers? Which registers are being dealt with? And then the ALU performs those electronic calculations. Now, there are more accumulators. Many computers now have 16 or more registers. This is a very simple processor. This is basically the old 6502 formats. Even these codes are the 6502 codes. But modern computers, they will actually start processing multiple instructions side by side. They will have multiple processors, and there's lots of ways things have been speeded up because of it. But in their essence, this is what processors do. So you need to go away, be able to find out what the instruction fetcher does, the decoder does, explain the CIR, the current instruction register, the program counter register, all the pink ones are registers, the memory interface, what does that do? What's the memory address register? What's the memory bus register? What the accumulator does, what the ALU is, the arithmetic logical unit. So all the bits on this slide need to be included in your presentation. Okay, there you go.